Okay, so I think we'll get started here. My name is Tom Purcell. I'm a consultant with Gyrates Solutions. Today's talk is by Michael Geers. He's author of Micro Frontends in Action. The name of the talk, Bye-Bye Front-End Monolith, Accelerating Feature Development in Micro Front-Ends. And so I guess my question for Michael is this the return of the multiple page web app?
Yeah, maybe it is.
All right, Mike, it's all yours. Michael, it's all yours.
Okay, thank you. Okay, so I have a lot of slides, so let's get started. Let's start with the monolith. I think every one of you knows what software monoliths are, so what the problem with a large software system, they are hard to change, they have grown over time, no one knows everything of this monolith. And in our industry, we started to break down these monoliths into, for example, into microservices. But over the last years, we've introduced, as developers, a new kind of monolith, so a front-end monolith. This monolith is oftentimes presented to you by the popular JavaScript frameworks like Vue.js, Angular, React, that make it very easy to build monolithic systems and with us feeling comfortable on just adding a new page, a new section to the application. And it feels the nicest when it's all part of this one application. And yeah, let's talk about forms of front-end monolith. So on the left side, you have the classical architecture where you have one piece of software, a monolithic system, which also includes the front end. This is how software was built for decades before. So you have the backend system, and it also has templating, and it's all one piece. In the middle, this is a popular evolution where the backend system and the front-end system diverged from each other or are decoupled from each other. They are oftentimes talk with APIs, and they often use different technologies. So having a JavaScript-based front-end system and some other language in the backend, for example. And on the right side, in the microservices world, we've broken down the backend monolith into multiple, smaller and easier to develop and to handle systems. But in many applications, we still use a monolithic frontend to talk to all of these microservices, often with some layer between, like GraphQL, a backend for frontend, whatever. But when we only look at the frontend, they're all monolithic systems with the problems that monolithic systems have. And over the last 7 years, I've been part of projects that implemented a different style of architecting a large application, which is not one of these three, but the fourth one, which is called now called micro frontends. And yeah, before I get started, let's talk a little bit about me. So my name is Michael. I'm a front-end engineer. You can find me on Twitter and GitHub and so on. I've compiled a site where I shared our learnings on microfrontends. You can find it at microservices.org. And over the last month, I've also written a book, which is called Microfrontends in Action. And I work for a company, a company based in Germany, northern Germany, and we build tailored e-commerce systems for larger companies. Okay, so this is the agenda. So the stuff I am going to talk about today. So the first one, first we'll talk about what microfrontends really are. Then I show you a little bit of the tech, so how to build, to implement microfrontends. Third one, I'll talk about why it can make sense to implement a microfrontends architecture. And the fourth one, I will address some of the misconceptions and myths surrounding the microfrontends topic. Okay, let's start with the first one. So what are microfrontends? It sounds a little bit like microservices, but maybe microservices just for the front end. Let's let's take a step back. So the term microfrontends was introduced in 2016. ThoughtWorks publishes their technology radar on a regular basis. And in this year, they added a term which they called microfrontends. And I read through the definition, and what they defined as microfrontends was the way we were working on client projects for, I guess, then 2 or 3 years now. And many other companies also are implementing this style of architecture, but previously there was no good word for describing what we were building. So 2016 brought us the name, and since then the concept of microfrontends and the things you can read about this concept has skyrocketed and has gotten more and more popular. More companies are adopting it. And over the years, in 2019, ThoughtWorks even moved the concept of microfrontends into their inner circle, into the adopt phase, which is saying we have good experience with building microfrontend style applications. It's definitely something you should look into. Okay, but what was the definition I just talked about? So this is from the ThoughtWorks technology radar. You don't have to read it. We go the 3 sentences. I go through them sentence by sentence and explain what this really means. So the first one, our preferred and proven approach to split browser-based code into microfrontends. This sounds a little vague. We can get some stuff out of it. So splitting browser-based software and microfrontends. Let's show an example. Let's get into splitting and cutting existing applications. In order for this to make sense, we have to introduce 2 concepts. So we have to think about pages, and there's another concept which you might not be familiar with, but I think it's very explanatory from its name. It's a fragment. And depending on the author and the framework and technology you see, what's called a fragment is sometimes also called an includable microfrontend, a portlet, parcel, pilot, whatever. There are multiple names, but the concept of fragments itself is always the same. Okay, let's start with pages. So as I said, we're building e-commerce systems. So our customers are large retail companies, for example, and their e-commerce systems have gotten so large that it's not feasible for them to work with one team on this complete application. And what we are doing there is looking at the customer journey. So what does the customer do? What stages is the customer in? So new customer lands on the e-commerce system. Maybe he looks for a specific problem, or maybe he exactly knows what he wants and needs more information on it. Or if the customer is in the stage where he has decided everything, he just wants to grab his stuff, pay, and get out. And we use this customer journey to split our application. So in this example, we have 6 pages, and the first 2 types of page, so the home page and the product list pages, are owned by one team. The product detail page is owned by another team, and everything regarding the checkout is owned by a third team. So pretty simple, right? Okay, let's come to the more interesting part, because the slide before was very rough, zoomed out, just on page level. But when we zoom in a little bit deeper, it gets more complicated. So on a typical product detail page, there are aspects also that are related to buying stuff and also finding new products that don't have something to do with the product you're looking at right now, or maybe they are related to the product you're looking at right now. So the use cases and the different responsibilities start to mix here. And this is where fragments come in. So team decide owns the product detail page, but the product detail page includes fragment. You can think of them as mini applications from other teams. And what this mini application is in practice, we'll talk about this later, but for the concept. Okay, number 1, now we have split our application into pages and into fragments. The second one, in this approach, the web application is broken down into its features. We just talked about this, and each feature is owned front end to back end by a different team. Now it's starting to get a little bit more interesting. So front-end to backend by a different team. We just saw the responsibilities with the team names. Yeah, and in our projects, we really have teams that are named like this. So we don't have a team which is called team product data, for example. We have a team which is called team decide, and they have a clear mission to help make the buying decision, to help the customer making a good buying decision. And all of our teams have missions. And if the question comes, we want to implement a new feature, which mission, which team is responsible, or which team should I talk to? The mission statements and their core responsibilities are the leading factor there. So the Inspire team does, for example, they send out newsletters, they do product recommendations, but also inspirational teasers, for example. And the other teams don't have to care about these kind of stuff. They can pull in the fragment if they like to enhance their page with content like this. And when we look at teams at systems level, we try to align, or not, we try to realign the teams we form with the systems they build. So typically, all of these teams build one system, which is self-contained. So it's able to function without the other teams being present. And each team is staffed with or built as a cross-functional team. So in an optimal case, we also have UX design capabilities, front-end, back-end developers, but maybe also data science and operations people, so that this team is really able to build everything it needs to ship their part of the system. Yeah, and the team have end-to-end responsibility. I just said that. And if you know microservices, you can think of the chart we are seeing here as a little bit larger microservices, so chunky microservices that also include their own front end. So they ship their own UI. And this is the next slide. So when we look at a page, for example, in the top right, we have this integrated page from team B, which has fragments, the blue one from team A, and two other fragments from team C. The customer sees the integrated version, but in reality, this page is stitched together via from multiple components. So we have the page which team B produces and the fragments that are contributed by the other teams. And then we have this magical wonder lamp on the top, which makes that everything fits together and gets to the customer. We'll talk about the wonder lamp a little bit later. Okay, so we are nearly done with the definition. Last one is, this ensures that every feature is developed, tested, and deployed independently from other features. So this iterates a little bit on the thing, the self-contained thing I talked about earlier. So here we have two teams, and both of these teams have their own version control system, for example, and they each have their own continuous delivery pipeline, and they have their own deployment process and are able to deploy on a Saturday night if they like to, but they don't have to coordinate with the other teams that they are starting to do a deployment, for example. So there's no thing that takes everything together and does a release process, for example. The idea is that every team has their own responsibility and capability to roll out new features if they like to. Okay, now after this theory, let's look at some of the projects we have been building and others have built. So the first example is a very simple one, but it illustrates that the micro-Frontends concept can also bring value just for pretty small projects. So in this project, we worked with two teams, each, I guess, around 5 developers. And the one team, the green one here, is called Team Cell. They handle the first part of the shop, so the homepage, listing pages, product detail pages. And then we have Team After Cell. They handle everything from the cart to the checkout to the My Account, for example. And a normal product page is mostly delivered by Team Cell. They do everything. They do the navigation, the product images, product data, whatever. but they include two fragments from the after-sale team. The first one is login status. So team cell doesn't know about the login status. They don't have to know about the login status. And the state of the mini basket. So if it's filled, how many items are in there, what's the total sum in there, something that team cell doesn't need to know about, but team after cell does, and they can show this information inside of their fragments. So, and now we go a little bit deeper into the process, and here we have a basket page, for example. And the basket page is mainly delivered by the after-sale team, but it shows the normal navigation we saw on the site before. And the after-sale team doesn't have to rebuild the complete navigation. They just use the navigation as a fragment from the cell team. Cell team provides this as a fragment. Yeah, and I've technically there's login status and mini basket are also fragments included in fragments, but you get the example. You get what I'm talking about. Okay, so now to a more sophisticated project. So 2 years ago, or 2.5 years ago, we started working with the Klingel Group, which is a German mail order company. They own 15 brands and operate in 12 European countries, and in total have a lot of shops, so above 60. And we worked on this project in a we rebuilt the monolithic front shop system into micro frontends with 5 teams that were staffed from 4 software companies. So we as a company, we had 2 teams in there, and there were other companies that also implemented their part of the system. And when we look at how a page on this platform is composed, it's getting a little bit more more complicated there, or a little bit more sophisticated. So this is the category page, and the category page has 2 inspirational elements. So the promotion banner on the top, the green one, and also a teaser. The header has 3 parts that indicate the wish list, the mini basket, the login status, which is in this project handled by a dedicated team. They just do everything regarding the after sale process. So if the customer has placed the order, tracking of the order, giving feedback, it's all the responsibility of the account team, for example. And if we go further, we see other, I go back and forth so you can see all teams play a role in many of these pages, but the combination, which is a fragment, what is a fragment, which goes where, is different from page to page. And here's a basket page. And in this project, the checkout team decided to not go with the standard navigation we saw earlier, but implement their own simpler one. But they wanted to show the inspirational element with the recommendations at the bottom, for example, and also use the feedback elements that team account provides. Okay, those were our projects, but we are not the only one, as I said before. So I want to show you one last example from PayPal. They have written the last month in the engineering blog how they are using micro frontends in their merchant account system, or on their merchant account area. And this is much cleaner than the screenshots from us you saw before. But here every rectangle is owned by a dedicated team. So you have one team that only does the PayPal account balance, for example, and everything that's related to it. Yeah, but we and PayPal are not the only ones. So this is an excerpt of a list of companies that are using micro frontends or developing tooling in the area of micro frontends. So we can assume that they're at least experimenting with the technology. And all of these icons provides a link to a blog post or to a GitHub repository where you can see code from them. And I will send you the slides later on, so you can dig deeper from the slide if you would like to learn more or see more in practice examples. Okay, so now let's get into how what you've seen before is been built in practice. We talked about cutting things into pages and fragments, and now we have these pages and fragments and have the the task to assemble them all back together so they make sense for our end user, because we don't want our end user to know that we're working with 5 teams. They don't care. So they just want to have a good user experience. And for doing this integration, we need mainly 2 concepts. So the first concept is composition. So how do we get fragments inside of pages? And the second concept is how do we get from page A to page B when these 2 pages might be owned by different teams. Let's start with the composition one, the first one, how we assemble different UI elements. So the easiest one is, and it's this feature exists for years now, is just to go with an iframe. If you're a web developer, I think the idea of building everything with iframes will not make you happy, because iframes have a lot of problems. They're bad for accessibility, for performance, for nearly everything. So iframes are really bad in many regards. But Spotify picked iframes as an integration technique for their web player and also their desktop application. And in this scenario, it made sense for them, because first page performance is not important for a desktop application, for example. And they get the benefit that the iframe provides nearly perfect isolation. So what happens in the iframe stays in the iframe. It's hard to get an error happening in the iframe to affect the complete outer page. But it also has limitations. So they're also working on putting their system on a new level. A composition technique that works on the server that we're using a lot for our e-commerce systems, especially for our customer-facing e-commerce systems. We also build back office tools where we have a set of other priorities regarding performance, for example. Using composition on the server eliminates a lot of issues and makes a lot of things easier. So here's an example how we leverage the SSI functionality, server-side include functionality that web servers or reverse proxies like Nginx, for example, have included, and you just have to activate them. In this example, the customer opens a URL for a RADAR. The Nginx or reverse proxy knows that the product detail page link, the RADAR, is owned by the team decide. It asks team decide to respond with markup for this page. And team decide responds with a markup, but it doesn't know about the state of the basket, and it doesn't know about a buy button, which should only also be displayed on the page. So it in this places it inserts placeholders. So these include virtual things are actually SSI includes, which have special meaning, and the Nginx now knows, okay, there are URLs in there. I have to fetch the content for these URLs as well. From team checkout, I can know that from the URL. Team checkout responds with the state of the basket and the buy button, and the Nginx stitches all of this together and delivers an already combined markup to our users. So as the request reaches our customer, it's already assembled. But not in all cases is assembling on the server necessary or a desirable approach. So as I said, we're also building back office applications, for example, and we often go with a full client-side approach. So having a Vue.js application, for example. And in this scenario, there is the concept which is called custom elements, which is part of the web component standard, which is for a few years now supported in all major browsers, which we can leverage there. So the team who owns the product detail page, in the places where it wants to include a fragment, it doesn't need to fetch the markup, but it just includes a web component, which is then owned by another team. So let's look at the related products box, the green one on the right side. So in the place of the box, the team owning the product detail page just inserts this inspire reco with the correct SKU for the recommendations that should be shown there. And the implementation, so what this means, what product should be shown there, isn't important for the team owning the product page, but it is an implementation detail for Team Inspire. and how Team Inspire compiled their markup if they do an AJAX call to fetch HTML from the server, if they decide to fill this custom element with a Vue.js application on its own, that's up to them. So we have decoupling on this level. So yeah, including a fragment is just including a web component, and the actual implementation is hidden from the user. Okay, this is composition. But now let's talk about page transitions. So how do we get from page A to page B? The most simple solution is, yeah, just use links. So this is pretty easy. But we have one challenge. Every team needs at least to know the URL pattern of the pages they want to link to. So Team Inspire has or Team Decide has to formulate to publish a URL scheme for the others to read. And if you can assemble a product detail URL with this URL scheme, you're able to link to a product detail page. And yeah, this is pretty easy, right? But since we are living in a world of single page applications and where we are trying to eliminate the classical reload page navigation, so clicking on a thing that reload the page and the next page looks very similar, but we actually looking at a completely different page. With this SPA, the single page application model, it gets a little bit more complicated. In the easiest version, so the left one, we are talking about linked single page applications. So Team A builds a single page application for maybe the home page and the listing page, and Team B also has a single page application, and links inside of these single page applications can be soft navigation. So just client rendered, changing the URL via JavaScript page transitions, which are quick and feel very nice. But links between this but links across teams, so from single page application from Team A to Team B are implemented as a hard navigation. So if you cross the team boundary, you get a hard navigation. This model is fine in very, very many cases, but it definitely depends on the scale you are running it at and how many pages one team owns and what the typical usage patterns in your systems are. So if the user crosses these boundaries on a regular basis, maybe from a product list to a detail page, and you see they're jumping a lot, there may be value in eliminating this hard navigation between the single page applications. And a concept that came up there, and there's a lot of systems and libraries around this, is the application shell. And the application shell is, I'll go to the next slide. Yes, the job of the application shell is to route, to do a soft navigation between different single page applications. And in order to achieve this, our application shell needs to be a shared piece of infrastructure. So every user that comes into our application first comes into the application shell. The application shell looks at the current URL and decides, with this URL, which single page application should I start? Should I start single page application from Team A or from Team B, for example? And if the user wants to navigate across different single page applications, the application shell has to stop one SPA and start the target SPA, for example. So this is the job of the application shell. And there is a very popular project which I'd like to highlight here, because many other projects either are heavily inspired by this one or plainly building on this one, and the project is called a single SPA. So this one is a more of a library than a framework. It's a ready-to-use application shell. It has integrations for nearly all frameworks. So it's very easy to wrap your Vue.js, Svelte, Elm, whatever you're trying to build application in a way so that single Spark can handle this page transitions for you. And it also has a solution for doing composition. So you can just do the web components way I showed you before, but they also have their own adaptation or their own implementation on doing composition in there. yeah, and I've also included a slide with a lot of other libraries. I've updated it today, and at least a handful of new popular libraries with more than 100 stars or 1,000 stars on GitHub have arrived in the last month. And we see more and more companies building tools like Luigi, for example. It's a project built by SAP, was released last year. This ice stark you see in the top right is a project which is built by Alibaba, and it doesn't exist for, yeah, it's a pretty new project. Okay, so now we know a little bit on how to build micro frontends. Let's talk about the why. So why should I care? Why is this a goal we should pursue? What are the benefits on using this architecture? The main reason why our customers go for this micro frontends approach is to optimize for faster feature development. And I'll explain what I mean. So Jessica and Kent just talked about that teams and team sizes matter, and growing a team has nonlinear effects on productivity. So if you have 3 8-person teams, they are very likely to be much more effective than having one 25 or 24 person team, because the 24-person team has a lot of overhead. They have to communicate a lot to each other to get stuff done and don't step on each other's foots. But for this model to work, we need an important thing, which is decoupling. So this is a photo op I took with my children. As you can see, there are 3 people on the road, and if their task is to run fast and run down the road, it will be far more easier for them if they can run on their own, so that they have everything they need. And in this picture, you see their shoelaces are tied together. And running in this state, so where you have to coordinate with your left or right neighbor, with every step you're making, you will get pretty slow. So it's important to think about decoupling and giving the teams the ability to move on their own pace and do their own thing. Let's look at this concept on a diagram level. So on the left side, we have a specialist team. So this is it relates to classical microservices architecture, where we have a front-end team, we have different services teams, so attribute service, content service, payment service, whatever, maybe also platform teams, depending on how you want to organize it. And on the right side, we have a more micro frontend style cross-functional team setup. So we have team inspire, decide, checkout, the teams we know from the slides before. And this each team is equipped with people that are having different skills. And now let's look what happens if we are tasked to build a specific feature, maybe add recommendations to the product detail page, or maybe add customer reviews for the product detail page, for example. And in the cross-functional team approach, so on the right side, we will very likely have people with every skill inside of one team. So the team can build the feature on its own. Maybe different people of this team have to get active and to work with each other, but it can all be happening in the right team. And on the left side, we have different teams that need to be active to build this feature. So we have the front-end team, we have the content service team, and we also have business people, and they have to talk to each other to get a clear vision on what they're building. They have to talk about interfaces between these different systems. They have to have meetings, and the most important one, they have to wait for each other. So they all have their own backlogs, and prioritization is not always the same in all of these teams. And the left one, that's the assumption for most of the features, the left one will be smaller. Yes, you might have features that also in the right model where multiple teams have to do stuff, but in most of the cases, the normal requirements can be done by one team. Another great effect or great benefit from having each team ship their own UI is that each team has direct customer feedback. So if there's a problem with the software, maybe the recommendations are not displayed correctly, it's very easy to pinpoint which team should get active right now. And you don't have pure API teams where you don't know if this team is responsible or another team, or if A relies on B. These are things that you don't have in this microfront and more monolithic sliced systems. Yeah, and the technical advantage is, but it's the same advantage you have with microservices. So you have smaller units, and it's far easier to renovate these smaller units. So if you decide to maybe upgrade your front-end technology, your checkout team is of the opinion that Elm is definitely better for doing the checkout than React. And they want to diverge from the other teams and migrate their front-end application from React to Elm. I think we have a talk with Richard later on where he can talk about the benefits of Elm, but it's not about Elm here. But the important thing is that deciding on a technology, the decision of a technology change can in most cases be made just in this one team, and the rebuild only has to be in this one team. So you don't have to change all of the system just because you have a special use case in there. Okay, let's get to the last part. So common micro front-end misconceptions. There are a lot. I only address 3, I guess, here, but you can ask questions later on. So the first one is micro frontends produce an ugly tech mix. So you already saw a few slides where I've mixed React and Vue.js and Elm with each other. And there's definitely the possibility. So the abstraction is that every team, every system is self-contained, and you have the possibility to do whatever you want in there. But it depends on how you're handling it, how you play this game. Yeah, here I've highlighted a Twitter thread from Jules Gleck. She is a software engineer and has worked on League of Legends, which is the browser-based game. And in this Twitter thread, she describes how they've adopted the microfrontends pattern in their browser-based game and how it didn't work out. So they had hopes for specific things, and she describes in smaller pieces how it turned out in reality. So they ended up with an unstable system where deployments from one team affected things of the other team. I can't go into detail on this, but what I wanted to say is that adopting microfrontends is definitely not a silver bullet which will solve every issue you're having, reduce complexity, whatever. It's mostly up to what you're building there and how you do it. The recent the last technology radar also introduced a dedicated term for this, which is called microfrontends anarchy. And I've added the subtitle which is called "Just because you can doesn't mean that you should." So having the decoupling on a level where each team can choose their own technology doesn't mean that it makes sense from a business perspective, for example, if you go Wild West on there. So in our projects, we typically when we get started, try to get an agreement, especially for front-end technologies, across all teams, and define a sensible default, for example. We have a blueprint, a starter kit, where new teams that come in can grab the starter kit with an opinionated tech stack, and they can just go and run with it. And what we employ in parallel to this is a channel where the different teams or people from the different teams can exchange knowledge, learnings with each other. So on a Slack channel, on a Slack channel with a low barrier of entry, but also in weekly, bi-weekly short meetings where teams tell what they've built and how they what worked for them and what didn't. So you have an alignment across the teams and the directions these teams are going in. And if you think back to the tie together shoes, yes, avoiding anarchy is a high goal, but avoiding coupling is also a goal. So this is a trade-off. So if you try to overregulate, so dictate that every team has to use tabs instead of spaces, for example, I think you're going too far there. But it's finding the right balance between giving teams freedom to move fast and letting them move in all directions at once. Okay, this is one of the most common sentences I hear. So microfrontends are bad for performance for different reasons. I think you can think of some. On this slide, I've shown the result of a German magazine which analyzed 50 German fashion e-commerce shops and ranked them via page with page loading speed, so using the last contentful paint metric here. And what I've highlighted on the right side is of these 50 e-commerce systems, 6 of them, I know from 6 of them, maybe there are more down below, but I know from 6 of these systems that are building, that they've been built with a microfrontends architecture. So the upper four ones are actually built on the Klingel group, so the examples with the many boxes you saw earlier, but there are also a few others in there that are not built by us. So that doesn't prove that microfrontends make your site fast, but it proves that microfrontends sites can be fast, but they can also be slow. So it mostly depends on what you're building with it and how you build it, what decisions you are making. And the additional question I mostly get with regarding to performance is, but what about the redundancy? I talked about systems that should be self-contained, and self-containment is not for free. So if every fragment, every page ships their own version of Vue.js, for example, there will be a lot of JavaScript in the browser, which the customer has to deal with and which might not be optimal. And there are 2 solutions to this problem. And I like to go with the first solution, which is gotten very unpopular, but I think it's worth stressing it. If you're using tools that don't have a large footprint, then the redundancy resulting in this decoupling we're having is also becoming negligible. So in the Klingel group project, for example, we are using Preact and HyperApp, so very small libraries that add just a little bit of runtime and JavaScript to the actual page. But if you go with an Angular application, for example, the overhead of the decision of using Angular will get you a lot of JavaScript you get by default, regardless of your fragment being very small or being very complicated. So it depends on the decisions you are making. But if you decided to go with a more larger library because it's more comfortable for your developers and or it's easy for to find people that know this technology, for example, there are also ways to deal with this redundancy. And there are 2 very modern techniques, which I would like to highlight here. So the left one is called import maps. Import maps is a feature which is present in Chrome for a few months now. And this is the ability to place libraries in a central place and letting bundles like Webpack bundles, for example, link to these libraries. So you having a Webpack build and say, okay, Webpack, don't include Vue.js, for example. There are 2 versions of Vue.js on a CDN. This is the location of the versions, and just reference the existing one. And multiple applications then can just do the referencing and not including the library in their own code. And this reduces the bundle size of each application and fragment. And another very cool approach is module federation, which is a feature which was included a few months ago in Webpack 5. And this is pretty related, but it's on a peer-to-peer, it has a peer-to-peer approach. So with module federation, you're building your JavaScript bundles in a way that they are chunked and that bundles from different builds can look if an existing bundle is already present on the page. So if we have application A, for example, which brings Vue.js, and the creators of this bundle A have marked Vue.js as something that can be shared, and you load the code from library B. Library B can check if Vue.js, for example, is already present in the page, if the version is matching, if fulfills all of the requirements, and it can just link to the existing version and omit its own download. So this is a pretty cool approach to lazy loading of larger applications. Okay, now I'm getting to the end. As I said earlier, I've written a book over the last months. And if you might have seen from my presentation, I like to do diagrams and charts and illustrations. My book has 270 pages, and most of them contain illustrations or code samples or listings. I have a special coupon code you can use to get a little bit off the price of the book. I think it's also valid for other books from Manning. If you, like me, enjoy reading code and learning by reading code or clicking through examples, all of the examples from the book are available at the-tractor.store, which is a page I created while writing this book. So you can go through there and test out an application shell, for example, and look what code is involved in creating an application shell from scratch, or how the same implementation would look if you just use single spar, for example. And you even need more after having consumed all of this. Here's a link, a list of links. So microservices.org is the site I've been talking before that I created myself. But there are also articles, blog post series from other peoples of the community, also a very cool, awesome list with even more links than you see here. Where you can dig deeper into this topic and see what others are doing and see other takes on this architecture. Yes, and my last book recommendations, I'm not affiliated with the authors of this, but it's very interesting and tackles same issue, but on an organizational level. So Team Topologies talks about how to equip teams, how to structure teams in a way that they're able to move fast and can produce output in a meaningful way. So good book to read, also with many illustrations. And I think that's it. So thank you for listening and stay healthy. Thank you.
Okay, Michael, thank you. Good talk. We have some questions here in the Room A Slack channel. So I'll start firing them off. How's that sound?
Yeah,
okay.
Sounds good.
Matt Kelso asks, how does this approach work when you have a shared design system? Who owns this? How do you handle changes to the DS that cut across different groups?
Yeah. Over the time, we've implemented two different approaches. So the first approach we've used in projects was a bootstrap style. I like to call it bootstrap style design system. So having a single JavaScript file, or maybe multiple JavaScript files, but a single instance of the design system included on all of these pages, and then having a bootstrap style documentation where teams can copy and paste HTML code, take them into their systems, just add classes to the right things. And this one is pretty easy to implement. You don't have to do much to get started with this. But evolving a design system that's built like this has turned out to be not that easy. So if you have buttons in two states and in two different states and want to introduce a third one, this might be easy, but going from 4 states to 3 states and having deprecations turned out to be quite complicated, or making changes in the grid which will introduce breaking changes. This was not so easy to do. What we end up doing with all our recent projects is provide the design system, the pattern library we call it, as an NPM package. So we have one team usually which starts building the design system for all of the other teams. This team coordinates a lot with the existing teams, and maybe is also staffed by people from the teams. And this design system is pushed out on a regular basis with versioning scheme. So every team can upgrade the pattern library in their own pace. So you have an easy way to handle breaking changes. But you also get redundancy. So if team A uses the button, team B uses the button, both teams will end up with the CSS of the button that may be in the same version, maybe in different versions. But in reality, even with this redundancy, it's much more performant because you have the ability to only ship the CSS you're actually needing, and not all of the CSS that a bootstrap style pattern library would introduce into into all pages.
Okay. Ken Ripple has actually a couple of questions. I think some of this you may have addressed, but I'll ask it. Where do you see the benefits of independence becoming overtaken by the weight of pages with shared team involvement? I assume each included fragment adds load times and performance impact.
Yeah, as I said before, so it really depends on what you're building. So if you're running with an approach where most of the fragments code is server side, so you don't have much JavaScript overhead, then there's no difference between a monolithically rendered product page or a micro-frontends rendered product page, because the assets that reach the customer are pretty much the same. With CSS, there is redundancy, but in our projects, if performance is critical, we try to watch for bundle size, and the overhead. A simple fragment introduces, we watch this pretty early in the process. We install performance monitoring so that we can address issues pretty early in the process and don't notice it later on.
Okay, Ken has another question. It has to do with, I guess, debugging. Are these harder to trace because you have multiple stacks in one browser separated by web packing, namespacing, building for dev versus source maps versus building for prod?
So as you would ship, each team would deliver its own JavaScript bundle. Debugging usually is pretty easy because you see a stack trace, and the stack trace can, in most of the cases, be traced back to a JavaScript file that introduced it. And you may have weird issues where an error in one will trigger, or misbehavior in bundle one will trigger a weird effect in bundle two. But this is I'm not quite sure if we even had this in production right now. So in most of the cases, the JavaScript errors are pretty easy traceable back to the team that's owning it.
Okay. And Matt Kelso has another one. What are some strategies for ensuring users are always seeing the latest version of a fragment? How do you avoid users having to hard refresh because it's cached in their browser?
I'm not quite sure if I'm get the versioning right. So fragments are in production, or in all environments, we only have the latest version of the fragment. But I think the case here is I'm on the product detail page, and the team who does the recommendation strip just did a new release, and the newer version of the recommendation strip will get online. And do we reload the page? Do we do an in-place upgrade? So in practice, we didn't have issues where this was very critical for the success of the site. So having the user come back later, and even for back office tools, it's in most cases where users are sticking in these tools for multiple hours. It's in most of the cases perfectly fine to leave them with the older version, support the older version, but when they come in next time, they just see the new JavaScript and CSS assets, and then they see the updated one.
Okay, all right. How do you handle, this is again from Matt Kelso, how do you handle features that overlap? Say you're using a Redux pattern and feature A wants some piece of state that comes from feature B.
We are using state management patterns like Redux, for example, but we don't share state on this level. So all of these applications or pages, fragments, whatever, they would have their own Redux store. A part I've skipped from this presentation is how we deal with communication, for example. Maybe you change the product, the color of the product, and you want the recommendations to be updated. And there we have a common theme that may be different from project to project, but we have strategy, we have a pattern for communication which all teams adhere to. So we are working with custom events, for example. If something happens in a fragment, it can bubble up an event which the rest of the page can react to.
Okay. Okay, somebody, it looks like Mal Kelso's typing in one more question. Great. Oh, he just says, great, thanks for answering.
Thank you.
Okay. All right. I think that's it. I think that's it. Michael, thank you very much. This was very interesting. Very interesting.
Thanks for
I enjoyed it a
having
lot.
me.
Okay. Hope to see you next year. Take care.
Yes, sounds good. You too. Bye-bye.
Yeah, in person, actually, right?
Yes, I would like to come in person.
Okay. Great. Thanks a lot.
Okay. See you.